Hey everyone, want to welcome you all back from spring break. I hope you had a nice, relaxing vacation and a good break away from all of your academics. I know it's kind of a crazy time and situation going on in life, but hopefully you were able to find some time to relax and take joy in some of the nuances and the simplicity of life. But we're going to get back at it here. So you can see today's lesson is Unit 10, Day 7, and we are going to be talking about the volume of pyramids. Now, it's been a while, over a week, since we last started talking about shapes, and Miss Flowers did a video lesson on how we would do the lateral area and surface area of pyramids. Today we're going to take a look at the volume, which again is how much space is inside of the shape. So, based on our two learning targets, we can see that by the end of this lesson, we want to be able to derive the formula in order to figure out what the volume of a pyramid is. And then we want to use that formula in order to solve problems. So the first thing I want you to do is I want you to take a look at this picture in the warm-up. And it says, given a pyramid in a prism with the same base and the same height, how many pyramids do you think would fit inside of the prism? So, for example, if we were to fill that pyramid with water or sand and then pour it into the prism, how many times could we do that until the prism is full? So take a guess. Is it just one time, 2 times, 3 times, 4 times? Just kind of take a mental note of that. And what do you think that is? How many pyramids could we pour, for lack of better terms, into a prism to fill it? Okay, so you've got that number. Let's see if we were right. And actually, I'm going to fast track this just a little bit. Killer music. Right there. So that's after 1. Fill up a second pyramid. And 2, we're not quite there yet. So is it 3? Is it 4? And there it is. So after 3 pyramids, we were able to fill the entire prism. So if your guess was 3, great. If it wasn't, no big deal. But since 3 pyramids fit inside of 1 prism, I want to know, how does the volume of a pyramid relate to the volume of a prism? Well, obviously, if it takes 3 pyramids, that means the volume of a pyramid is 1/3 the volume of a prism. If it takes 3 pyramids to equal 1 prism, then the volume of the pyramid is 1/3. Now, little recall here. It says that since the formula for the volume of a prism is V equals B times H, how can we alter this formula to derive the formula for the volume of a pyramid? Well, if the volume of a prism is B times H and the volume of a pyramid is 1/3 of that, we can either write that as volume is 1/3 BH, or volume is B times H, capital B times H, over 3. Okay. Either one of these will get you the appropriate answer. Now remember that B is the area of the base. Okay, so it's not just a side length, and that's a common error that gets made in pyramid problems. So we want to find the area of the base of the pyramid. We want to multiply that by the height of the pyramid, and then we can either multiply that by 1/3 or divide it by 3. Either way, it works out the same. Okay? So let's jump into an example here. The pieces of information we need the area of the base, we need the height. When I look at the base, I see that it's 12 across and 12 wide. So 12 times 12 comes out to be 144. The height is always going to be this internal measurement from the vertex straight down to the middle. And we can see that that height is 21. Therefore, if I want to know the volume is 1/3 times the area of the base, 144, times the height. So, if we do this here, and I'll just do this first one on the calculator so you can see how that works out. 1/3 times 144 times the height of 21, and we can see that we get an exact answer of 1008. Now, our unit is feet, and remember that when we are using volume, we cube our unit. So 1008 cubic feet. Okay. Now, if we take a look at the second example, we need B, we need H, the area of the base, it's 10 by 10, so 10 times 10 is 100. Now, notice this piece right here, this 13, is not the height. It's starting at the apex, or the vertex, but it's not going straight down to the middle of the base. It's running along the side. So this is actually what we call the slant height. So if you refer back to the lesson when we talked about lateral area and surface area, we found this slant height by using Pythagorean theorem. Well, we can work backwards off of that for Pythagorean theorem as well. If I were to draw this height straight down and then connect the bottom of the height to the edge, we can see that we have this right triangle here, where the hypotenuse is 13, and this bottom side is not 10. Okay, the entire length across is 10, so the bottom is 5, half. So now I can set up a Pythagorean theorem problem to find the height. So Pythagorean theorem, 5 squared plus b squared equals 13 squared. If we subtract the 5 squared from both sides, 13 squared minus 5 squared is 144. We take the square root of that, b is 12. So this missing piece, which is the height, is 12, and we can plug that in. I now have the two pieces of information I needed, capital B and H. So volume is 1/3 times 100 times 12. 1/3 times 100 times 12 comes out to be 400 centimeters cubed. Okay. And those are basically those two types of problems. Looks like we're frozen up here, so let's try this again. There we go. Okay. So if you're given the height, perfect. Okay, there's nothing more you need to do. However, if you're given the slant height, we use Pythagorean theorem to work backwards in order to find the height by using that slant height and half of whatever the base length is. Okay? So if you're feeling confident and comfortable, I'm going to ask that you try examples 3 and 4. There's one of each of the two examples like we did in 1 and 2. And when you have answers, go ahead and feel free to resume the video and check it. If you're still not feeling comfortable and you want to see more examples explained, go ahead and continue watching. Example 3, we see as a pyramid. We need the base, we need the height. The base is 12 by 12, which is 144, pretty common number for this worksheet so far. And then we have this measurement here of 10, and we can see again that's the slant height. So I draw my regular height in, I connect it along the bottom. The slant height is 10, the bottom is half of 12, which is 6. I'm going to do my Pythagorean theorem. 6 squared plus b squared is 10 squared. 10 squared is 100, minus 6 squared is 36. 100 minus 36 is 64. So we take the square root, and this missing side is 8. That missing side is the height of the pyramid. So we're ready to go. We've got the height, we've got the area of the base. Volume is 1/3 times the area of the base times the height. 1/3 times 144 times 8. That comes out to be exactly 384 inches cubed. Okay, and then on the last one, we need an area of the base, we need a height. We see 3 along the bottom. We don't have any other measurements, but given that it's a pyramid, we can assume that that's going to be a square as well. So 3 times 3 tells me that the area of the base is 9. Now, this 5 is written on the outside, so we might be thinking it could be a slant height, but notice the direction that the arrows are pointing. They're straight up and down. They're not slanted or running on an angle. It's straight up and down, so 5 is the height. We have exactly what we need. Volume is 1/3 times the area of the base times the height. 1/3 of 9, this one we can do in our heads. 1/3 of 9 is 3 times 5 is 15. So that's going to be 15 feet cubed. Okay. So that's our volumes of square pyramids or normal pyramids that we're accustomed to seeing. But remember, pyramids could have any shape base. So I want to just look at 2 more examples in which the base is not a square. The formula doesn't change. The formula is still 1/3 times capital B times H. But the process that we use in order to find capital B is going to be a little bit different. Okay, so I still need capital B. I still need H. Now, notice for capital B, or let's start with the easier one, height. Height is 12. Capital B is the area of the base, so it's important to recognize what shape the base is. Well, I can see that the shape has 1, 2, 3, 4, 5, 6 sides, which is a hexagon. Now, we learned a nice formula last unit in order to find the area of a hexagon. If you don't remember what it is, we'll review that now. It was 6 times s squared, where s was the side length, s squared root 3 over 4. So s squared is 9 squared root 3 over 4. And when we do that, 6 times 9 squared root 3 divided by 4, that comes out to be 210.44. 210.44. So now I've got everything I need. I've got the area of the base, got the height. Volume is 1/3 times the area of the base times the height. And that comes out to be 841.76. And we are not given any units here. So that's just going to be units, sorry, not squared, cubed. Okay. So one more time here. When we have a problem, looks like we're frozen again. Whenever we have a pyramid and we want to find the volume, it's going to be capital B times H divided by 3, or 1/3 capital B H. Capital B is the area of the base, and we spent a whole unit previously before break finding the areas of different shapes. Okay, so if you want to try example 6 based on example 5, go ahead and do that. If you want to just watch for another explanation, go ahead and do that as well. In example 6, we can see that again we have a pyramid, so the pieces of information I need are capital B and H, and they were so nice as to already tell us what H was. Capital B is the area of the base. 1, 2, 3, 4, 5, 6 sides again. So it's going to be 6 times 7 squared root 3 over 4. 6 times 7 squared root 3 over 4 comes out to be 127.31. So that's the area of the base, the bottom. So in order to find the volume, it's 1/3 times 127.31 times 24. So 1/3 times 127.31 times 24 comes out to be 1018.48. Again, no units are given, units cubed. Okay, and that does it for this lesson. Okay, so there's no assignment for today. That'll be tomorrow. You'll have an assignment based on this video lesson. Your job was just to watch, take down some notes, and shoot me or Miss Flowers if she's your teacher any questions or concerns that you have. You can send us a message through Schoology or through email, and we'll be more than happy to address that for you. Again, welcome back. I wish it was in person, but we're going to do the best of what we can with what we've got. So thanks for watching. Please make sure that you guys take care of yourselves and stay healthy, and hopefully we'll get to see you again soon. Have a great day. We'll talk to you next.